How are we going to show that this has exactly one real root? Use the what? Use the mean value theorem, exactly. In order for the mean value theorem to apply, what has to be true about this function? It must be what? It must be continuous, is it? Yep, sure is. It is continuous. Nice. Now what do? Take the derivative. So you're going to start, the derivative of this function, sorry. I'm going to start with the derivative of, taking the derivative of this right here. So f prime of x is equal to 101x to the 100 plus 51x to the 50th plus what? Plus 1. Okay, you took the derivative. Now what? It's what? You notice that f prime of x is always positive, so always increasing. Okay, so that just tells you it's always increasing. So you're showing it has exactly one root. So what next? So now you have to show it crosses the x-axis. How do you do that? Plug in values, right? Like f of what? How about f of 0? What's f of 0? Negative 1. What's f of 1? 1 plus 1 plus 1 minus 1 is 2. So what does that tell you? It's continuous, and it goes from negative to positive. So what has to exist where? So f of x must equal 0 where? Yeah. Somewhere between what? 0 and 1. That is correct. Somewhere between 0 and 1 it must cross. So now you've shown that it has at least one. You've shown that it has at least one. Now you have to show what? Yeah, now you want to show it has exactly one. How are you going to show it has exactly one? Correct. So what would you say if you wanted to write this as a sentence? What would you say?
Because the equation is always increasing, it can never go down and cross the axis and down.
Okay, so this is okay, but it's not. It can never turn around, so there can never be a what? That's okay, but you could. We did this a couple times in this class. You could assume that there's two roots. You could assume that there's two. Do you remember? Assume f of a equals f of b equals 0. Right? Do you remember what theorem which states that what? So there exists a c contained in AB such that what is true? F prime of c such that f prime of c equals 0. But that's a contradiction since what's true? F prime of x is always what? It's always positive. So there can't be what? 2 zeros. So there can't be 2 zeros. It's not cool. What is f of x? What's f prime of x going to be?
2 plus sin x.
2 plus, yeah, you have to use the product rule right here, right? The derivative of the first times the second plus the first times the...
Not negative.
Oh, cosine, I'm sorry. Still waking up. Not negative. Cosine x all over what? Plus sine x. So you have what? You already told me this, but it's 2 plus sine x plus x cosine x all over 2x plus x sine x. Then it asks you to find the second derivative. What do you have to use, unfortunately, to find the second derivative here? You're going to have to use, must use the quotient rule. I mean, it's not impossible. I mean, what's nice about derivatives, they might get ugly, but you have a direction to move in, right? Low d high minus high d low. It's pretty disgusting, right? But if they say use your calculator, let's use our calculator a little bit earlier. Sound good? So it does. I'd imagine it does. So let's go back to window and you would -5 to 5. You said. Oh, the scale should be 1. Sorry. -5 to 5. That's kind of cool. I mean, do you see the natural log function in there? It's getting larger, right? But what is it doing? It's oscillating as it's getting larger.
Yeah.
That's kind of cool. So what are we going to type in here? I'm going to type math 8, right? But what am I going to type in now?
y2x.
Y2. And what do we think about the speed at which it's going to graph this thing? Because, well, first it's going to have to do the derivative, right? It's funny how it doesn't, notice how it doesn't have any memory too? Like, I mean, short-term memory. Every time I hit graph, what is it doing?
So,
Oh, look, it kept it. Oh, wow. Thank you for proving me wrong on record. So it's graphing it, isn't it? Whoa, sweet. Is that kind of cool? I mean, it's kind of like some weird version of some old video game.
it's high-tech technology these days.
It is super high-tech technology these days. You know, again, we can put someone on the moon. Well, not really because we don't have a shuttle anymore. But we have really pixelated centipede-like graphics. Nice. Okay, so we have the second derivative right now. If f double prime is negative, what does that mean? Concave down. And then if it's positive, second derivative is positive, it's going to be concave up. Now another way you